Okay, this is part three, and what I have in front of you on the screen is, as you look at your schematics, this would be uh, fuse 2 would be glitching intermittently. That's the fuse feeding the ignition coil relay. So if we had an intermittent fitment in the fuse box at that fuse, this is basically what would happen. So this is our glitch. You can see the current in red stop flowing, which makes sense because we have that open in fuse 2. It looks about the same distance, about 300 milliseconds. Our crank sensor's good because our PGI main relay is good and working. Our purple and our yellow guys are strong. We can see them. They're going to be charging voltage, as you can see there. That's 1485, and our yellow guy about 1386. Let me get a better reading on purple. Basically, that's our feed to the PCM, which is good. So we're okay. Yeah, about 1357. So I know we're charging on purple, and we're charging on yellow. We're also good on gray. That is the ignition feed terminal at ECM pin E9. As you look at your schematic, our crank sensor is good. Our blue guy is the current flowing through the PGI main relay from fuse 8, and I'll look at that, and I'm going to say that we got about 80 milliamps flowing through there. That's at channel A, blue, so we know that relay is working properly. The problem lies in the, as I said, we're glitching at fuse 2, so current stops flowing through ignition coil relay. So we know that this current and this current will be the same. So let me look at the delta in red. This time I have a delta, not like I had at the end of the second video. So this is good, and this is a total open in that relay control. Let's see what that's going to equal. Okay, that delta is looking about 89 milliamps, which is probably about right for that relay. So let me look at the delta on burgundy, which should be the same. It's the same current. So here we go down here. Now I've got thick lines, so we're not going to get it perfect. I'm going to go in the middle on both. Okay. What's our delta there? Okay, 84. See, we got good corroboration. That's pretty much, it's the same physical current flowing, so I feel a little better that I explained that. I know I didn't do a good job at the end of the second video, but you kind of get the idea of the Ohm's law part of this this training video, how you know, when current runs in parallel, that the sum total of that would be the summation of it. So anyway, that's a situation where we're glitching intermittently at fuse 2. Let's see the next one, if I have one more to share. Okay, here we go. Okay, this is interesting. Remember, I talked about test points. This should be the finale. I just want to talk about our scope. We just made a little change. We're going to make a little change in our adjustment on scope channel C green. As you're looking at your schematic, you look at pin E7 at the PCM. You see where the test lead is, and above that, that would be the little green dash there. That would imply an intermittent connection. And then the dotted line is a test point before the intermittent connection. So let's take a look at one and then the other. So right now, let's kind of look what's going on here. We can even determine from the schematic, right at that spot, at that point of your schematic where you see that little green dash, right below where the purple channel is going to pin 8.2. You see that little green dash. If we were intermittently open right there, let's look what would happen. we would have it as if our test point in this schematic would be high. The green guy would go high. You can see it. Look at the green guy. The green guy's going high. That is that would imply from that test point, our test point would be the dashed green line, and then the glitch is below that, more toward the PCM. That voltage would go high, and that would unlatch both relays. So now we're starting to make sense. Okay, with both relays unlatched. Okay, yellow's down, purple's down. Okay, as you can see there, purple and yellow are down. No current flowing through blue or red. So this would tell us that everything kind of would make sense as far as where the glitch is and where our test point is. Our test point would be at the dashed green test point, and where it glitched, our voltage would read high. So that's starting to make sense. And there's no current flowing through anywhere through burgundy, red, or blue with a high voltage there. Let me go to the final one, and we're going to move our test point, and it'll look different. So I just want to tell you the value of knowing where your test point is when you're scoping. Real important. And that should do it. Okay. Let me see if this was my right video, and it'll make sense. Okay, that's it. This should be it. Okay. Now this is a situation now. Look at your schematic. This is the original setup when we started shooting all this stuff. Okay. We can see our green guy's low. We're open. There's no hash. There's no action on that wire. It's sort of like that's like ghost voltage for that lead. And in this scenario, we have no current flowing through red, nothing through blue, nothing through burgundy, and this is the crank's not working because it can't get any power. The only guy strong is the gray, which is charging voltage, which is not charging voltage, it's basically battery voltage the moment it goes away. Basically, that's going to be a strong 12 volts. That's a different circuit. So if we had a scope on the PCM, we'd know where to look for this problem because we're good at gray, and that's a different feed. Like we would not suspect the ignition switch in this situation. So you look at that little spot in your schematic, that little green spot where the glitch is, and with our test lead on the PCM side of that glitch, obviously this would tell us something. So you look at that schematic, it all starts to make sense. The crank went away, and both relays stopped flowing control current, and injection and spark would go away. Anyway, hope you enjoyed this video, and this is a Tactical Technician, and signing off, and thank you very much for watching.